Hi, Algebra 2. We're going to take a look at our 8.6a samples where we're going to be graphing equations of conic sections. That's our parabolas, our ellipses, our hyperbolas, and our circles. We're going to graph those conic sections that don't happen to have either a center at the origin or a vertex at the origin. We'll include important features, and we're going to see what those important features are as we work through some sample problems for each of those conic sections. So starting with sample 1, we're presented with this equation, x plus 3 squared plus y minus 4 squared equals 4. And based on what we have already written in our lesson work, we're going to recognize that equation as a circle that is not centered at the origin. So I've just put this in a thinking bubble. That's the first thing I want to do. I want to figure out, okay, what is the shape of my graph? In this case, it's a circle. So I'm going to go ahead and find the center of my circle. Whatever I see next to my x, I'm going to write down the opposite of that number, so -3 for my x-coordinate of my center. Whatever is next to my y, I'm going to write that number's opposite for the y-coordinate of the center of that circle. Then I can go ahead and put that point on my graph, -3, 4. My next step will be, once I have my center graphed, I've located it, I know where it is. Next, I'm going to figure out what the radius of my circle is, which I will use to finish my graph. I use this 4 since we know our x squared term plus our y squared term is equal to our radius squared in a circle. Radius squared is 4, the square root of 4 is 2, so our radius is 2. So now I'm going to start at the center of my circle. I'm going to count off 2 to the right, 2 up, 2 to the left, and 2 down. Put points at all of those locations. Draw my circle through those points that are 2 to the right, 2 up, 2 to the left, and 2 down from my center. And then I'll go about labeling my points. For my points that are right and left of my center, I know they will both have y-coordinates of 4 because they're at the level of 4 high. And then I will count off 2 to the left, -3 going to the left gives us an x-coordinate of -5. -3 counting 2 spaces to the right, -3 plus 2 is -1, so there's my x-coordinate of -1. Then for my ordered pairs that are above and below my center, they will all have an x-coordinate of -3 because they're 3 to the left. And then starting at my y-coordinate 4, I'm going to count up 2. 4 plus 2 is 6, and then counting down 4 minus 2 is 2 for my y-coordinate of my ordered pair down here below my center. And now I have all the important features. I have my center and its ordered pair. I have the 4 points I used to draw my circle and all the ordered pairs labeled. Next problem. Let's take a look at a situation where we're given an equation that actually is a parabola. Again, looking back at our notes on this lesson, we're going to recognize this as a parabola because we see a y squared term and an x term. No x squared here. So this is a parabola that does not have a vertex at the origin. So we're going to go ahead and figure out where that vertex is. We're going to notice it's opening right since it's a y squared parabola, and we're going to notice that this 4p here is positive, so therefore it's going to open right. So the y squared tells us it's going to open either left or right, and this tells us, because it's a positive value, that it will open right, not left. All right, let's get our vertex. So the vertex will be the opposite of the number next to the x, -3, the opposite of the number next to the y, so +1. So our parabola is going to open on this vertex, -3, 1. We don't really know how wide or how skinny it's going to be. We're not too concerned about that at this point, so we're just going to open it to the right somehow, some way. And then we're going to find the focus. We're going to note what the focus is, and then we'll be done with our graphing here. To find the focus, we're going to remember that this number here is 4 times p, so 8 is equal to 4 times p. Dividing both sides by 4 gives us a p-value of 2. That means that our focus is going to be 2 spaces to the right. Our focus has to be inside of our parabola. That's how we know to move to the right. And because our p is 2, we're going to know to start here and move 2 spaces to the right to find our focus. So we'll start at -3. We'll move 2 spaces to the right. -3 plus 2 is -1. The y-coordinates, of course, are going to stay the same because this is a horizontal segment here. So we are done with our graphing. We've noted the focus. We've noted the vertex and labeled them with the correct ordered pairs. We've drawn a parabola opening to the right, not being too concerned with how fat or how skinny it is, and that completes our sample 2. Sample 3. So we're going to notice that this one is in the form of an equation for an ellipse. We have x squared over either a squared or b squared plus y squared over either a squared or b squared equals 1. In this case, our a squared is going to be underneath our y squared because it's the bigger number, and our b squared will be underneath our x squared. It's the smaller number. So we're going to note in a thinking bubble here, this is an ellipse with a major vertical axis. That just means that we're going to be going up and down more than we are going to be going left or right. Let's find the center of this ellipse. So the center will be the opposite of the number next to the x, -2, the opposite of the number next to the y, so +1. So there's our center, and we put it down. Then pull off our a squared and our b squared. So here's our a squared, 16, so a is 4. Here's our b squared, 9, so b is 3. So we're going to start at the center here that we've already figured out as -2, 1. And then we're going to use the a and the b numbers to go up and down, left and right, the appropriate number of spaces. So since we have a major vertical axis, that means that our A4 is going to take us up and down. So we will go up 4 spaces. So we'll add 1 plus 4 to get 5. The -2 will stay the same because we're still 2 to the left. And then we'll take 1 minus 4. 1 minus 4 is -3. And again, that x-coordinate must stay the same because we're still 2 to the left. Then we're going to use the b number to go right and left. That is our minor axis. So we'll start here at -2, 1, and we'll move to the right 3. And notice this time that it's the x-coordinate that's going to change. We're still at the level of up 1. So -2 plus 3 gives us our 1 for our x-coordinate. -2 minus 3 gives us our x-coordinate, -5. So we have our center noted. We have all of the ordered pairs up, down, left, and right on our ellipse here. And so we're drawing our ellipse through those points. They're all labeled with the correct ordered pairs, so that completes sample 3. Sample 4, the last type of conic section we're working with here. We're going to work with a hyperbola. In this case, we know it's hyperbola. We still have our y squareds and our x squareds over some numbers in our denominator, but notice we have a minus sign this time. Remember, for an ellipse, we're going to be adding. For a hyperbola, we'll be subtracting. And of course, we're in standard form since we're equal to 1. Let's pull off the center of our hyperbola. We'll look next to the x and pull that number off for the x-coordinate center. So the opposite of -1 is 1. Then we're going to pull off the opposite of 3. Opposite of 3 is -3 for our y-coordinates. So remember that when we're looking at our x and y coordinates for our centers, they pair with whatever variable they correspond to. So this will give us the x-coordinate. This will give us the y-coordinate. Okay, so we've got our center, 1, -3. We'll put that down in our graph. Then we're going to pull off our a squared and b squared. So remember, for a hyperbola, a squared is always under the first fraction, and the b squared is always underneath the second fraction in the denominator. So a squared is 1, so a is 1, b squared is 36, so b is 6. We're going to use these numbers now to move up, down, left, and right of our center to find our rectangular box that will allow us to find our asymptotes that will allow us to then graph the branches of our hyperbola. So starting here at 1, -3, I'm going to go ahead and use my a to move up and down 1 because I know that I have a vertical major axis. I have a transverse vertical axis, which means I'm going to be opening up and down once I have plotted these points. So this 1 here is telling us to move up and down 1 from our center point. So if you add 1 to -3, that's -2. If you take -3 and subtract 1, you get -4. And then for the values that we need to move to the right and to the left, we're going to use the b number. So we're going to start at our center and move 6 to the right. 1 plus 6 is 7. 1 minus 6 is -5. Of course, our y-coordinates will stay the same. They're still down 3. Once we have all of those points labeled, we draw our box. We draw the asymptotes through the corners of those boxes. Then we can open up the branches of our hyperbola that we know must open up or down because this is a hyperbola with a transverse vertical axis because the y squared term comes first. All right, that completes our samples for this lesson. Please make sure you refer back to these as you are working on your quiz for support, and we will see you next time in our next lesson.